Somewhere out beyond the edge of what we can comfortably explain, the universe is quietly doing things that refuse to make sense. Not because we lack data, not because we aren't looking closely enough, but because even with our best telescopes, our most advanced physics, and our most confident theories, certain objects in space simply do not behave the way they are supposed to. And the unsettling part? These aren't rare rumors or fringe ideas. These are real observed phenomena, tracked, measured, debated, sometimes for decades. So the question is not whether the universe is strange. The question is, how many things are we still misunderstanding without realizing it? Let's step into some of the most baffling objects in space, where every answer seems to create two new mysteries. The object that shouldn't exist, Oumuamua. In 2017, astronomers detected something extraordinary, an object racing through our solar system at high speed on a trajectory that clearly showed it came from interstellar space. They named it Oumuamua, a Hawaiian word meaning messenger from afar arriving first. At first, it seemed like just another asteroid, but almost immediately it began to behave strangely. It wasn't following a perfect gravitational path. Something was pushing it very slightly, but enough that it deviated from expected motion. That alone would be intriguing. But here's where it gets unsettling. There was no visible cometary tail, no gas, no dust, nothing that should produce acceleration. Even its shape was bizarre. Based on its light reflections, scientists believe it may have been extremely elongated, or even flat, like a thin object tumbling through space. And then came the speculation storm. Was it a comet made of exotic materials? A fragment of a shattered planet from another star system? Or something far more unusual, like a massive, thin structure pushed by sunlight itself? Most scientists lean toward natural explanations, but none fully resolve all observations. And the object is gone now, never to be seen again. No second pass, no detailed close-up, no final answers. Just a brief visit from something we still cannot fully explain. But here's the real question that lingers. If the first confirmed interstellar object already behaved this strangely, what else is already passing through unnoticed? The star that dimmed without warning. Tabby's star. If Oumuamua was strange because it was fleeting, Tabby's star is strange because it refused to be ignored. Officially known as KIC 8462852, this star sits about 1,500 light-years away. In 2015, astronomers noticed something deeply unusual. Its brightness was dropping in unpredictable, irregular patterns. Not gently, not periodically, but dramatically, sometimes by more than 20%. To put that in perspective, a planet like Jupiter would only dim a star by about 1%. So whatever was causing these dips had to be enormous. And unlike normal planetary transits, there was no consistent pattern. At one moment, the star would dim slightly, then suddenly plunge, then recover partially, then behave completely differently weeks later. Naturally, explanations were proposed, a swarm of comets, debris fields, or dust clouds, but none fully matched the data. Then came the more speculative ideas, ones that made headlines worldwide. Could it be a partially constructed megastructure, an alien Dyson swarm gathering energy from the star? Most astronomers reject that idea, and there is no evidence of artificial origin. But even the natural explanations remain incomplete. What makes Tabby's star so unsettling is not that it is mysterious, but that its mystery refuses to settle into any stable explanation. It behaves like something we should understand, but don't. And even today, after years of study, it remains one of the most puzzling stars in the galaxy. So what else might be dimming in ways we simply haven't noticed yet? The universe's loudest whisper. Fast radio bursts. Every so often, radio telescopes pick up something extraordinary, a burst of energy from deep space that lasts only milliseconds, but releases more energy than the sun does in days or even years. These are called fast radio bursts, or EFRBs. At first, they were assumed to be one-off events, maybe the result of a rare cosmic cataclysm like a star collapsing into a neutron star. But then, scientists discovered something even more confusing. Some FRBs repeat. The same location in space emits multiple bursts, sometimes irregularly, sometimes in patterns that hint at periodic cycles. That alone shattered early assumptions. Catastrophic events shouldn't repeat. So what is causing them? Possible explanations include highly magnetized neutron stars, called magnetars, or exotic astrophysical processes we are only beginning to understand. Some models suggest extreme magnetic activity could produce these bursts. But even those explanations don't fully account for all observed behavior. Some FRBs appear to come from environments that don't match expected magnetar locations. Others show unusual frequency patterns that don't align neatly with known physics. And here's the most unsettling part. We have only been detecting FRBs seriously for a short time. The sky may be filled with them, constantly firing signals we are just beginning to notice. Imagine standing in a dark field and suddenly realizing the night sky is not quiet at all, but constantly flashing with invisible signals we only recently learned how to hear. So the question becomes, are FRBs rare cosmic events, or are they a normal part of a universe we barely understand? The invisible giant, dark matter. Now we move from objects we can see behaving strangely to something we cannot see at all, but know must exist. Galaxies rotate in a way that doesn't make sense under known physics. Stars at the edges of galaxies move too fast to be held together by visible matter alone. Without something extra, galaxies should fly apart, yet they don't. Something unseen is providing additional gravity. This mysterious substance is called dark matter. We cannot observe it directly. It does not emit light, absorb light, or reflect light, but its gravitational influence is undeniable. Scientists estimate that dark matter makes up about 27% of the universe. But here's the problem. No one knows what it actually is. Over the years, many candidates have been proposed, weakly interacting massive particles, axions, sterile neutrinos, but none have been confirmed. Experiments deep underground, designed to detect rare interactions, have so far come up empty or inconclusive. And yet, without dark matter, our understanding of galaxies collapses. So we are left with a paradox. Something invisible appears to hold the universe together on a massive scale, but we have no direct evidence of what it is made of. And this leads to an uncomfortable thought. What if dark matter isn't a thing at all, but a sign that gravity itself behaves differently on cosmic scales? That idea is controversial, but it shows how little we truly understand about the structure of reality. The even bigger mystery, dark energy. If dark matter holds galaxies together, dark energy does the opposite. It drives the universe apart. In the late 1990s, astronomers discovered something shocking. The expansion of the universe is accelerating. That means galaxies are not just moving away from each other, and they are speeding up as they do so. Something is pushing space itself outward. We call this force dark energy. But again, we don't know what it is. It appears to make up about 68% of the universe, making it the dominant component of reality as we understand it. And yet it remains completely invisible and unexplained. Is it a property of space itself? A quantum field? A breakdown in our understanding of gravity? No one knows. And here's where it gets more unsettling. If dark energy continues to dominate, the universe may eventually expand so rapidly that galaxies become isolated islands, stars burn out, and the cosmos fades into a cold, dark emptiness. So, in a very real sense, this unknown something is shaping the ultimate fate of everything. And we still don't know what it is. The rogue messengers from space, interstellar meteors. In 2014, a small object entered Earth's atmosphere and exploded over the Pacific Ocean. Years later, analysis suggested it might have been the first known interstellar meteor. Unlike typical meteors, its speed and trajectory hinted it came from outside our solar system. But what made it even more interesting was its composition and strength. Some studies suggested it might have been tougher than expected for a natural rock. This sparked debate. Was it just an unusual asteroid, or something with an origin we don't fully understand? Even now, the data is limited, and conclusions remain controversial. But it raises an unsettling possibility. Interstellar objects may be entering our solar system more often than we think, and we are only catching a tiny fraction of them. So, how many are passing through unnoticed? And what might they be carrying? The planet that should be there, but isn't, Planet 9. Beyond Neptune, the outer solar system behaves oddly. Certain distant objects have clustered orbits that seem influenced by something massive and unseen. This has led to the hypothesis of a hidden planet, often called Planet 9. If it exists, it would likely be several times the mass of Earth in orbit far beyond Pluto, taking tens of thousands of years to complete one orbit. But despite years of searching, no direct observation has confirmed it. Some astronomers believe its gravitational signature is real and compelling. Others argue the observed clustering could be observational bias, or the result of smaller objects interacting over time. So far, Planet 9 remains hypothetical, but it represents a fascinating kind of mystery, not something detected and unexplained, but something inferred and still missing. If it is out there, it is one of the most distant members of our solar system, hiding in plain darkness, cosmic rays that defy physics. Occasionally, Earth is struck by particles from space that carry mind-boggling amounts of energy, far beyond what we can produce in our most powerful accelerators. These are ultra-high-energy cosmic rays. Their origin is still uncertain. Some likely come from supermassive black holes or active galactic nuclei, but not all detected events fit neatly into those explanations. Even more puzzling, some particles appear to arrive with energies that challenge known acceleration mechanisms entirely. It's as if the universe has particle accelerators far more powerful than anything we can imagine, and we are only catching stray fragments of what they produce. The cosmic structure we still don't fully understand. On the largest scales, the universe forms a web-like structure of galaxies and voids. But even here, anomalies exist. Regions that are unusually empty or unusually structured in ways that challenge standard cosmological models. Some areas appear colder or emptier than expected. Others show subtle irregularities in background radiation that remain debated. Are these just statistical flukes, or hints that our models of the early universe are incomplete? We don't yet know. So, what does all this mean? If you step back, a pattern begins to emerge. We are not dealing with one mystery, we are dealing with many, spread across every scale of the universe. A wandering interstellar object that doesn't behave like it should. A star that dims unpredictably. Radio bursts from deep space that repeat without clear cause. An invisible substance holding galaxies together. An unknown force driving the universe apart. Possible planets we cannot see. Particles with impossible energy. And structures in the cosmos that don't quite fit our models. Each one, on its own, is fascinating. But together, they point to something deeper. Our understanding of the universe is still incomplete in ways we cannot yet measure. And here's the final thought that tends to linger long after the data fades. The universe is not hiding its mysteries from us. It is revealing them gradually, on its own terms, at its own pace. And right now, we are only at the beginning of listening. Because if space is already full of things we cannot explain, then the most important discoveries may not be the ones we have made, but the ones that are still quietly on their way toward us.